Hello there and welcome to part 4 of this video log documenting my entry to the Element 14 Community Sci-Pi competition. In today's episode, I'll be talking about the latest on the project. It's been a challenging time, I would have to admit. We've had some issues, which were my fault, namely a corrupted SD card on the Raspberry Pi, which led to me having to rebuild the web server. Some issues which weren't my fault, such as Google pulling support for the TensorFlow Lite model maker package, which I was using for audio classification. But let's focus on the positives, because this week I have, at last, finally been able to finish the CAD. So we have all mechanical parts now ready to be able to 3D print, hopefully over this weekend. I took delivery yesterday of this quite exciting looking green filament. I'm looking forward to getting the parts off one by one. Now let's take a look at the design. Yes, it is quite green. First of all, obviously, as you can see, the main feature of it on top is this big 3-watt solar panel, and that's positioned at a 35-degree angle, which for UK latitudes is considered to be the best for catching the most sunlight possible. Now, underneath that, we have the body tube containing the electronics and the battery. And underneath, your attention will also be drawn to the ground spike, being able to push it into the soil next to whichever plant you're trying to measure the bees. I've also designed an alternative base for it, which takes the form of this slotted base. That's because, in my case, I want to position the sensor next to a planter which contains strawberry and lavender. So being able to sit it directly on the edge of the planter lip would actually be most convenient for me. Now those, when we start to disassemble it, should simply just remove by friction fit from the base. So let's go ahead and hide those components. And now what we're left with is the sealed body tube. That too has a friction fit at its top, so if we pull that down, what we're looking at now is an inner body tube. I've gone for a 2-wall design, as the PLA filament, which I have to print with because my printer cannot do ABS, is not the most waterproof, and I didn't want to attempt to rely on a single wall to seal it. So as a result, I thought the best way to stop any moisture getting into the electronics would be to use 2 walls and an air gap. The inner wall too can now be removed, and that reveals the cradle for all the electronics inside. The 18650 lithium-ion battery at the bottom, and then in the main electronics bay, the HC12, if I just toggle a section view now so you can have a look, the HC12, the Raspberry Pi Pico, and at the top, the largest board, the Solar Power Manager. This quite large piece here in black is a representation of the size of the jack that has to plug into the Solar Power Manager, which is where the cables from the solar panel are fed in there. I've tried to do my best to think about cable runs and where it's all going to fit in, so it isn't too much of a headache to put together, but I'll let you know next week how I got on. Now the cradle itself also friction fits into a base plate here, and that is where, on top of which, is mounted the little microphone, which sits inside here. Now this microphone, obviously we need to allow sound to reach it, clearly from nearby insects, but at the same time I didn't want to allow insects and grub and other muck to be able to get into this area where it could potentially interfere with the microphone. So although these windows are shown as open, I intend to line them with a perforated foil piece which will have apertures small enough not to allow hopefully flies and grub and stuff through. The largest 3D printed part is on top, and it's going to be quite a difficult one to print, I have to admit, but I wanted to design it as a single part, not to give it any joins where water could potentially get through. It's the cradle for the solar panel, of course, and it has this channel here to allow the cables from the solar panel itself to reach the main body of the sensor. Now this part obviously fits nicely onto the rest of it. I've decided to rely entirely on friction fit joints throughout it. I didn't want to, given that it's a prototype, glue anything in case it needs to be taken apart, which it almost certainly will, many times. So I wanted to compromise and find a way that it would hold itself together without needing any permanent fixings or glue. So that's about it, really. In terms of waterproofing features, as well as the double wall that I've mentioned, I'd also like to draw your attention to this particular little lip, if you like, above the windows, clearly supposed to direct any water coming down the main body tube away from where it could potentially get into the microphone bay. But I'd also like to say that the reason why the entire sensor is hidden underneath the solar panel itself is because the solar panel is waterproof. So I hope that the solar panel will do the job of being able to direct away the vast majority of rain that might fall on the sensor. So there we have it. It's been quite fun to design. I do like designing quite compact things such as this, and then inevitably giving myself a huge problem when I come to assemble it and fitting cables through. But we've been there before, so hopefully nothing to worry about. I'll let you know next week how I got on, and in the meantime, I hope you have a lovely week. See you next time. Bye for now.